Hey there. Welcome to the chillest STEM robotics class ever, where building a Bluetooth-controlled car is as easy and fun as pie. Ready to snap together and steer your future supercar? Just imagine all the cool stuff coming up. No need for inhaling that soldering smoke or getting your fingers stuck to the table with hot glue. Trust me, been there. Ouch. We're just using Lego Technic bricks. So simple you can even dance to your favorite tunes while building. With the Arduino Nano board working as the smart brain, complete with a motor control module, wiring is a breeze. It's easier than deciding whether to eat pizza in bed or at the table. And if programming makes you sweat bullets, chill out. Our drag and drop code block system lets you just drag and drop like playing with a puzzle and watch the magic happen. It's easier than figuring out what to have for dinner. Let's get started.
Alright, let's get started. Open up the magical drag and drop software Mixly for Arduino. The command blocks here look absolutely stunning, sparkling like candy. First, pick a lovely Arduino Nano board for the connection. Remember to choose the correct COM port or it won't run. Let's begin. Load a blank code like a fresh sheet of paper to clear out old programs. Drag and drop those digital write commands onto the stage. Next, bring an analog write command onto the floor. Pick any pin you like, but let's go with pin 4 to control the motor's direction. When set to high, the motor spins smoothly, but which direction depends on your wiring. Choosing low reverses the motor's direction, just like a game. Next up is pin 5 to control the speed. Crank it up to 255 to max out the speed, or down to 0 to put it to sleep. We'll keep the motor dancing at 100. Load the program and see how the motor performs. Aha! The motor is spinning counterclockwise. Try switching to low and see how the motor spins now. Reload the code and find out. Now the motor is spinning clockwise. Lower the speed to 50 and see how it performs. Oh, it's spinning like in a slow motion film. Easily count each rotation. Set the speed to 0 and see if the motor stops. Yes, the motor has stopped at speed 0. When pin 4 is set to low, it's well behaved. Let's see how it performs at full speed, 255. See how it does. Wow, the motor spins like a rocket. And now, program to stop the speed and let it rest a bit. Moving on to more exciting parts, copy the commands to control another motor. Super fun! The second motor uses pin 7 to change direction based on high or low. So easy to remember. Pin 6 will control the second motor's speed. Unstoppable. Keep pins 5 and 6 at 100 and see if they run together. Set high on pins 4 and 7. Let's see what happens. Woohoo! Both motors have reversed directions. Set the speed to 0 and see if they both stop. The two motors still rotate and do not stop. Now set pin 4 and pin 7 back to low. And indeed, when pins 4 and 7 are low and speed is 0, the motors stop. Start with an even cooler program. Group the commands into a single representative command. Call it backward sounds professional. Clone that command and change it to forward for style. Set high for pins 4 and 7. Make the car move forward spectacularly. Copy immediately to create a left turn command for smooth driving. Change one wheel's direction for a stylish turn. Show off those driving skills. Create a stop command. Set pins 4 and 7 to low quickly. Keep speed at 0 to ensure the car rests safely. Now you've got 5 awesome car control commands. Let's test big. Program the car to go backward for 1 second, then stop. Oops, I overdid it. Delete and drag another command. Okay, load the program and let the car run. It worked correctly. And it's time to delete the test commands. Onto Bluetooth. Get ready. Declare baud rate in the setup. Create the Bluetooth variable to receive signals from the app. Bring the if-else command onto the control stage. Program Bluetooth to receive signals via serial. Note, if you want to upload a program with Bluetooth, remove the module first. Assign the value received from the serial port to the Bluetooth variable. Select the command to print the Bluetooth variable value to the monitor screen. Press button to load program. After uploading, plug the Bluetooth module back in for a big success. Bluetooth signal indicator is flashing red. Choose JDY10 to connect. Can't miss. Try hitting some buttons on the app. See how the car runs. So exciting! Click the monitor button to see how the values are received. In the state of not pressing any button, we get the number 83. When we press the up arrow button, we get the value 70. When we press the down arrow button, we get the value 66. The left button gives a value of 76. The right button gives a value of 82. We do the logic as follows. If the Bluetooth variable is 83, then execute the command to stop the two motors. And we do the same logic for the remaining situations like forward, backward, left turn, right turn with the corresponding comparison numbers. Now we need to remove the module Bluetooth to be able to load the code. The code has been loaded. We proceed to plug the Bluetooth module back into the board. Select the connection named JDY10. Finally, the car can move by Control app. Now we can control the car to move and perform tasks in the robot game. Have fun playing with your Bluetooth-controlled car.